Welcome wherever you are. So I want to take you through briefly in Organic Chem 1. And then in Organic Chem 1, we will talk about the alkanes, alkenes, and alkynes, how to name them, the chemical properties, and the physical properties. After that, we will do some questions, and then we will go to Form 4, where we will look at Organic 2. In Organic 2, we have alkanols and alkanoic acids, polymers. We will look at them, how to prepare them, and the chemical properties. After that, now we will embark on how to deal with the flowcharts. So I want you to be patient and learn. Organic 1 is basically the study of hydrocarbons. What are hydrocarbons? Hydrocarbons are compounds which are made up of carbon and hydrogen atoms only. So a compound which is made up of carbon and hydrogen is called an hydrocarbon. So hydrocarbons have been classified into 3 groups, and these groups depends on what? The type of bond that exists between the individual carbon atoms in the molecule. So we have classified them into 3. Number 1, we have alkanes. Alkanes, these are hydrocarbons in which carbon atoms are linked by a single covalent bond. That is the most important thing you need to understand. That alkanes, these are hydrocarbons where the bond is a single bond between them. So we will have like this, where every carbon atom must be surrounded with 4 covalent bonds. 1, 2, 3, 4. 1, 2, 3, 4. So this one is an alkane. Alkanes, they have a single covalent bond. Single covalent bond. Number 2, we will talk about alkenes. What are alkenes? Alkenes, these are atoms held, or in alkenes, the carbon atoms are held by at least 1 double bond. We can have 2 double bonds, but at least there should be 1 double bond. For example, the functional group, actually this is the functional group for alkanes. And the functional groups for this one is this. So these are alkenes because of the double bond between carbon atoms. These are alkenes because between carbon atoms there is a single bond. So that is the difference between alkanes and alkenes. In alkenes, the bond between the carbon and carbon is a double bond. Then lastly, we will talk about alkynes. This one is called alkynes. At least they have 1 triple bond. So here, alkynes, this is how they look like. So there is this, and there is one there, another one there. So this is the functional group. We call it the functional group. This is the functional group for alkynes, and this is the functional group for alkenes, and this is the functional group for alkanes. Thank you. So let us move ahead very fast. I don't want to take much of your time. Let us look at the alkanes. We have said these are hydrocarbons in which only a single covalent bond is present in the molecules. Alkanes are said to be saturated. This word here, saturated. What do we mean that they are saturated? A saturated organic compound or saturated organic compounds are compounds in which each carbon atom has only single covalent bond throughout the structure. So alkanes, like I have shown you, has a single covalent bond throughout. Therefore, they are saturated, meaning they are stable. That's why we are going to say that they do not undergo most of the chemical reactions because they are already stable. Stable meaning they are saturated. This word here, saturated. Actually, they don't react and hence cannot decolorize both bromine water or acidified potassium permanganate. They do not do that because they are saturated. Why? They don't react. They don't react because they are saturated. So therefore, if you have an alkane, it will not change the color of bromine water from yellow to colorless. Neither will it change the color of acidified potassium permanganate, which is purple, to colorless. So alkanes cannot do that. So when alkanes are burnt in air, they burn with a blue non-sooty flame. So alkanes burn with a blue non-sooty flame. That is nice. The next thing we want to look at is the cracking of alkanes. One of the sources of alkanes is cracking of alkanes. Actually, cracking is the breaking down of a long chain alkane to supply short chain alkanes. Long chain alkanes are broken up through the process called cracking of alkanes. That is nice. So we have two types of cracking of alkanes. We have one we call thermal cracking, and there's another one we call catalytic cracking. There is one we call thermal cracking and another one called catalytic. So why do we call this one catalytic? It is because there must be a catalyst. For this the reaction to occur for the catalytic cracking, there should be a catalyst. Thermal, the word thermal means heat. So for thermal cracking to occur, there must be very high temperature. So thermal cracking takes place at a very high temperature and only involves heating the long chain alkanes. Catalytic cracking takes place at a relatively low temperature and involves heating the long chain alkanes in presence of a catalyst and at low pressure. That is nice. So yours as a student, please make sure you know how to differentiate between thermal cracking and catalytic cracking. Actually, you should know the reason why we do thermal cracking is to break the long chain alkanes to supply with short chain alkanes, which has got so many uses, unlike those that have long chain alkanes. So the short chain alkanes have more uses, and they are more on demand than those that are long. Nomenclature. Nomenclature means naming. So we want to start naming of the alkanes. How do we name alkane? We are going to see that. But actually, because we are revising, I won't go into much details. But alkanes have a general formula of CnH2n plus 2, where n is a number 1, 2, 3, 4, all that. So as we are going to see that we are going to use this general formula to give the molecular formulas of the alkanes. So for example, when n is equal to 3, in the formula we are going to replace n, H2n plus 2. We are going to replace n if n equal to 3. So what do? We will say C3H. This is 2 times 3, 6 plus 2 is going to be 8. So that is an alkane number 3. So that is how we use the general formula. If you want the molecular formula of an alkane with 7 carbon atoms, you just write C7H. 2 times 7, which is 14. 14 plus 2, that is 16. And this is the general formula, so you can see. So 7, it is 716. So the first alkane, we call it methane. It is important that you master the names of the first alkane, the second to the, at least to the 10th one. So the first one you must know, you must sing, is the methane is the first one. Methane has what? Only 1 carbon for hydrogen. Therefore, methane is, this is the molecular formula. This one is called the molecular formula. So ethane is C2H6. Propane is the third one. Butane, pentane, hexane, heptane, octane, nonane, and decane. So this decane, it is number 10, it has 10 carbon atoms. Butane is carbon number 4, it has 4 carbon atoms, 10 hydrogen. Therefore, for you to master this, you need to read and reread, repeat several times so that you can master them. Once you master for alkanes and alkynes and even the alcohols and the alkanoic acid, is going to be very easy for you to master. Therefore, once you understand this one, you are good to go. So the first as we have did is methane, and this is the molecular formula. So the molecular formula is CH4. I want to show you that this is the structural formula. It is important you know the difference between structural formula and the molecular formula. So structural formula is the one we write when we open the structure, where we have the bonds. For example, for ethane, C2, so we write C1, 2, and then we put this hydrogens this way, this, that way, this way, this way. So how do we name branched alkanes, the one that has branches? First, the first thing you do, you identify the longest continuous carbon chain to determine the name of the parent. So once we want to know the name of the parent first, how do you know the name of the parent? You count to get the longest continuous carbon chain. Tunamaanisha unahesabu hizi carbon atoms, ile yenye iko the longest is the parent name. Kwa mfano tunaweza count 1 2 3. Kwa hivyo si ni carbon, so nimecount 1 2 3, nimekuja chini. Hiyo ni 3. Sasa tukwaje niende straight, itakuwa 1 2 3 4. It means this is the longest carbon chain. Therefore, the parent name is 1 2 3 4 is butane. That is the parent name. This one I will count the longest carbon chain is 1 2 3 4 5. It means the parent name is pentane. That is the parent name. So number the longest chain from the end of the chain that is near to the branch. In case there is a branch, you number the carbon atoms such that you give the branch the smallest number, right? Therefore, in this case, there is a branch here, so we start numbering from the left. 1 2 3 4. You don't have to number from this side 1 2 3, because you are going to give the branch number 3 instead of giving it the smallest number, which is number 2. Therefore, we number such that we give the branch the smallest number possible. So the substituent groups which we can have attached on the organic compound or on the hydrocarbon is number 1, the alkyl group. Alkyl groups are groups that we form when we remove one hydrogen from an alkane. For example, if you remove one hydrogen from methane, here you form CH3, you remove one hydrogen, you have CH3, and we call it methyl. So this group you are seeing here, this branch is called methyl. That is how we are going to name it. So this one is called methyl. The other one is ethyl. Where do we get ethyl from? We get it from the ethane. Ethane is C2H6. So once you remove one hydrogen here, you form ethyl group. Therefore, if you see C2H5, that one is called ethyl. Another substituent group we are going to encounter is the halogens, which are attached in end part of the carbon on the long chain carbon. Also, chlorine will be written as Cl. Bromine will have Br, and then fluorine you will find it as capital F. Iodine you will find it as A capital I. So I'm going to give you the way you will pronounce them. So let us look at this one. This is CH3. So the longest carbon chain here is 1 2 3. Even if you count 1 2 3 1 2 3, everywhere the longest carbon chain is going to be 3. Therefore, the parent name is going to be propane. And then we have, if I take this one to be the longest chain, this one and this one is a substituent group, is a group, and this group is methyl. As you can see, is methyl. So, but we have a methyl here and we have another one here. So, in case we have two or more, we indicate them by using di. Di means 2, tri means 3, tetra means 4. For example, here we have 2 methyl groups here. So we are going to say 2. For carbon number 2, here we count 1, 2, 3. So kwa carbon number 2, kuna methyl na kuna ingine. So we have 2, 2 dimethyl propane. So this is the correct name of this compound here. So this is 2,2-dimethyl propane. We can do more examples here. So let us give this compound the name. First, we need to give the parent name. We count the longest carbon chain. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. So the longest carbon chain here is the 4 carbon atoms. Therefore, the parent name is going to be butane. Right? The next thing we look at is the branches. So the substance group here, we have the methyl group. So we start giving this carbon the numbers, considering the one which will give this the smallest number. Here, 1, 2, we get this one. 1, 2, you get this one. Therefore, you can start tunaweza anza huku ama pande hii. So we have 1, 2, 3, 4. So here we are going to say on the carbon number 2, there is a methyl group. On carbon number 3, there is another methyl group. So we are going to say on carbon number 2, put a comma. Again, on carbon number 3, there is a methyl group. Because there are 2 of them, we say di, because of 2. And then what group was there is a methyl group. So you say dimethyl butane, the parent name, butane. Like that. In case the substituent groups are halogens, the one we have mentioned earlier, there is a way we write their names. If it is iodine, we say iodo. If it is bromine, we say bromo. If it is chlorine, we call it chloro. Right? If it is fluorine, we call it fluoro. Like this. So let me give you an example where we have these ones. For example, we can have this. So let us give this compound the name 1, 2, 3, 4, 5. The parent name is 5. 1, 2, 3, 5 carbon atom. 5 carbon atom, that is pentane. Pentane because the single covalent bond. As you can see, every carbon atom lazima isunguku. It must be surrounded with 4 covalent bond. 4 covalent bond. If you find that you have not surrounded a carbon atom with 4 covalent bond, then it means you are wrong. So the parent name is pentane. And then we have carbon, the substituent groups here, chlorine and bromine. So if I start numbering this side, 1, 2, 3, I will give this one 3. If I start here, I will 1, 2, 3, it will be number 3. So it doesn't matter where you will begin. For this one, you will start from anywhere. So let me start here. So you give the numbers here, 1, 2, 3, 4, and 5. So it means, now on carbon number 2, I have the chlorine. On carbon number 3, I have the bromine, right? Therefore, we now write them as 1, 2, we have 2 dash, we use this dash, chloro. Because it is chlorine, we use chloro, this one. And then carbon number 3, you put a dash, and then 3 is dash, bromo, 3 bromo. And then the parent name 1, 2, 3, 4, 5, bromo, pentane. And that is the name. After that, we have 2 halogens here. There is one which starts with C, another one starts with B. In alphabetical order, which one comes first? A, B, C. So B comes first. Therefore, this one is a wrong way of writing it. You must ensure that the bromo comes before chloro. Therefore, the correct now final is 3 dash bromo dash 2 dash chloro pentane. You must use alphabetical what? Order. Let us look at this one. The parent name is 1, 2, 3, 4, 5. That is pentane. That is the parent name. Now let us look at the substituent groups. We have halogens here, chlorine, bromine. So here we 1, 2, 1, 2. So we will start numbering from anywhere. It doesn't matter now. This time round. 1, 2, 3, 4, 5. So here we are going to have bromine. One bromine is on carbon number 2, another bromine is on carbon number 3. Chlorine, we have 2 chlorine attached on carbon number 4. And we have said B will come before C. Therefore, we will start with B. So we will have carbon number 2, right? Comma. Carbon number 3, there is a bromine. And because there are 2 of them, we will say dibromo. And then dash carbon number 4, again carbon number 4, 4, 4, 4,4. Yaani ukianza hapa utapata hii 4, tena ukirudia utapata another one kwa 4. Ndio maana tunaandika 4,4. So we use a comma to separate them. You don't need to use 1. Yani some people think that now since they are on carbon number 4, you will just use 4 to represent both of them. No. Each is attached on the top and then on the bottom. Therefore, this way. And then dichloro. And then the parent name pentane. So you realize this is starting with the dibromo and then dichloro. So this one, it won't matter which one will start. It is just fine. So the name is 2, 3 dibromo dash 4, 4 dichloropentane. That is the correct name for this organic compound.